And so many of the interest problems we get will be like this. We'll have an equation, they'll give us parts of the equation, and we'll need to solve for the other one. And so that's exactly what example 1 was as well, except it was really easy to solve for the one that they didn't give us. This one, it was a little bit trickier, but we just have to use the same log rules and algebra we know all along. This problem down here is a little bit different. It says, what is the effective rate? And so if you remember back from those first slides, the effective rate is the interest rate they would need to be giving us in an account that was compounded annually to make the same amount of money. And so the way we approach these problems is just kind of we do it by year. We say, well, how much would this account make in a year? And what would I need to make my annual rate to be to make that amount? So let's see how big this account would get over a year. So the account starts with 10,000, and then we multiply it by 1 plus r, so 0.05 divided by 12, and then since this is on a year, we'll just do 12 for the n times 1, right? So we know everything on this side of the equation. And now what about my mysterious rate, my mysterious annual count? So that would just be making, I'd start with the same $10,000, but instead, remember the equation for that is just 1 plus whatever rate the annual account is charging to the power of t, which in this case is just 1. So I can do a lot of simplifications here, right? This is 10,000 times 1 plus 0.05 divided by 12 to the power of 12 is equal to 10,000 1 plus r. The 1 power just doesn't mean anything. And so the 10,000s will cancel out. And I should get that r is equal to 1 plus 0.05 divided by 12 to the power of 12 minus 1, or that r is equal to 0.05116. So close to 0.05, but a little bit bigger, which is what we'd expect, because we see that those annual accounts make less than the accounts that where we compound it monthly, meaning that to get the same thing out of an annual account, I'd need a higher rate.